Okay, good morning, class. This is Unit 5, Day 2. We're talking about our transformations of cubic functions. So we're going to take a look at the parent function and see what happens when we move it. It's going to behave much like our previous functions, the quadratic, the absolute value, but we're going to add one twist to this one, just like we added that twist with our local maximum and local minimum. Okay, so you should have a copy of these page of notes from the teacher. And we're looking at our parent function, which is x to the third power. And here's what it looks like. So we're just going to be following this cutout of it as we make some transformations. So we're going to allow function g of x to represent what happens when you subtract c from your cube. So if we let c, let's do this in red. So if we let c equal, let's do a 2. So c is positive. In the past, when we had something inside the parentheses, it's our horizontal translation. And remember, it moves the opposite direction because there's a negative or a minus sign inside of here. So it's going to take our function, and since c is, the equation would be x minus 2, it moves it to the right. So every point gets moved over to the right. And you're going to see what a horrible drawer I am. So this one moved every point to the right. And so the change to the graph is called our horizontal. I'm going to be abbreviating horizontal translation. Typically, we call this left or right. So it moves to the left if your c value is less than 0. If c is greater than 0, we move to the right. And what happened to each individual point, our x values, we had to add c to each x. So every x value we added 2. Our y values had no change. Okay, so again, that's somewhat familiar. D, so this is outside parentheses or outside what the function does. It's always at the end. This takes care of our vertical translations. So commonly we would say it moves up or it moves down. And it will move up if d is greater than 0. It moves down if d is less than 0. So let's allow d to equal, how about 3? Let's take a look at that. So d is obviously positive. And what that does is it takes each point and moves it up 3. So this point was at -1, -1. It moves up 3. This point was at 1, 1. It moves up 3 until it's almost off of our chart here. So it'll look like that. And again, it's just the whole thing. If I was better at drawing, you would recognize it. Feel free to plug these into your calculator also. So in y1, you could put the parent function. And in y2, go ahead and put what the change is. So for example, this one we just did that I did not draw very well, if I put that in the calculator and graph it, let's see. It does look a little strange simply because of the weird curves within this function. So here's what it would look like. There's the parent, and there's the translated function. So it moved it up 3. And the way it did this is that our x values had no change, but our y values we had to add d to each point. Okay, so we're adding d to each point. Next one, again, you should recognize. This is when we have a negative sign out in front of the whole function. And remember, this one simply is a reflection. So it takes your points and reflects them across the x-axis. If they start out above it, they're going to finish below. If they're below, is going to reflect them above. Let's do this in a different color. So this point was at 1, 1. It's now going to be at 1, negative 1. If it's at 0, 0, it stays at 0, 0. This point's a negative 1, negative 1. It reflects upwards. So what it's going to look like is something like this. So again, this is the green line here, is our reflection. So the two of them together do look like two quadratics that are touching each other. But the way this one works is our x values, there's no change. Our y values are multiplied by negative 1. So every y value we multiply by negative 1 to see where it's moved or translated to. Okay, function k. We get this function when we take our cubic parent function and multiply it by a. So a is outside those parentheses. So if we remember from previous functions, this one does our vertical stretch or compression. We get a stretch if a is bigger than 1, and we get a compression if a is less than 1. Don't worry about the sign, whether a is positive or negative, because all that does is control whether it's reflected or not. The actual value of a will tell you the stretch or compression. So let's see what happens here. If we let a equal, let's do 3. Okay, so if we're letting a equal 3, it's bigger than 1, so it should stretch. And the way it works is it takes your x values and leaves them alone, so no change. Our y values are going to get multiplied by a, whatever that value is. And in this case, it's 3. So if we look at our graph, the point at 0, 0 stays at 0, 0. 1, 1, the x value stays the same, but my y value of 1 is multiplied by 3. So 1 times 3 is 3. So it's been pulled up there. Of course, it would continue going upwards. Our point of negative 1, negative 1, the x stays the same, so it's still negative 1, but y is multiplied by 3, so that goes down to negative 3. So this has been pulled upwards. And again, you might want to try putting this in your calculator so you can see it a little bit better. You might want to zoom in also so you can see the distinction here. Okay, let's take a look now at our new transformation. We had this previously, but we've never actually seen what it did. So in this case, we've got a b value. And this is the one that, with quadratics and absolute values, it really did the same thing, so you couldn't see what happened. But here we're going to see what really is going on. What does b cause to happen? First thing I want you to notice is that b is always inside the parentheses. It gets cubed along with the x. So that's really important to look at. Okay. So to find what b does, I want to tell you first of all, it causes a horizontal stretch or compression. So we get a stretch if b is less than 1. So notice this is the opposite of the vertical. We get a compression if b is greater than 1. And the way I try and remember this for myself is that things inside your parentheses are opposite of what you think. So when we had our translation, our horizontal translation, we moved the opposite direction of what C looks like. Likewise, when we have this B value, the stretch or compression are opposite of what you would think. I don't know if that helps you or not, but that's how I remember it for myself. And the way this works is it takes your X value and it multiplies each X value by 1 over B. It takes the Y values and there is no change. So let's pick a value here. How about we allow b to equal 1/4, okay? So if we let b equal 1/4, if I come over here and look at my graph, and let's look at that point 1, 1, the x value is going to get multiplied by 1 over b, which is 1 over 1/4. So if I was putting that in the calculator, it's 1 divided by parentheses 1 divided by 4. You want to make sure you have parentheses around the 1/4. And that equals 4. So my x value, instead of being at 1, it's actually multiplied by 4, which puts it over here. So it comes like that. Negative 1 also gets multiplied by 4, so that pulls it to this side, and it would come downwards. So this point has been stretched over to here. This point has been stretched to here. Again, I recommend playing with this one. Plug it in your calculator. Try putting in a b value of greater than 1. So put in a 2 or a 3 and see what happens. And what you're going to see, I'm going to draw this in red so you see it, is that when you have a large b value, this gets much thinner. But the way that it gets thinner is that it pushes the points inwards, horizontally. They're coming in together. Vertical transformations stretch it longwise. This does it by pushing points in. And again, plug in some values on your calculator. Okay, let's flip over to the back side and give this a shot. Okay, that top line, that is just giving you, let's just call this is our cubic transformation equation. So A parentheses B parentheses x minus c close parentheses cubed plus d. And a couple things to note here. The A is completely outside parentheses. The B is inside that first set of parentheses. Then you have a second set, so you have a single x inside this parentheses. You have to have x by itself when you're trying to figure out your horizontal transformation. So x minus c close parentheses to the third power plus d. So if we're going to describe these changes now, I can't fit it all in here, so we're going to write here. So A is responsible for reflections if A is less than 0. So if A is negative, you're going to have a reflection. It also takes care of vertical stretch, and that happens if A is greater than 1, or you get, and I'm just going to use the V here, vertical compression if A is less than 1. And again, this is regardless of the sign. So A could be a negative 3. The negative will make it reflect. The 3 will make it stretch. B is responsible for our horizontal stretch, and that happens if B is less than 1. It's a horizontal compression if B is greater than 1. So again, notice how these are the opposite signs here. Horizontal transformations are opposite of what you think. C is our horizontal translation, which really means it goes right or left. It goes right if C is greater than 0. It goes left if C is less than 0. There is a negative in the equation itself. So if C was negative 2, your equation would say x minus a negative 2, which becomes x plus 2 raised to the third power. D is our simple one that I always think is the easiest one, is our vertical translation. More commonly, we would just say up or down. So it goes up if d is greater than 0. It moves the cubic function down if d is less than 0. Sorry, I ran that together. Okay, so stay with me now, and we're going to take a look at some equations and see what is going on in them. I'm going to use some abbreviations. Instead of writing vertical, I'll just use the letter V. Instead of writing horizontal, I'm going to use the letter H. So as we look at these equations, the first thing we want to do is decide what letter each thing represents. So in this first one, the 2 is completely outside your parentheses. It's not cubed, so that's an A. The 5 gets cubed, so that's a B. And then C, is C positive 1 or negative 1? It's actually positive 1 because the negative is part of the equation. So let's fill in what happens. The A is greater than 1, so it's going to be a vertical stretch by 2. Again, that means every y value gets multiplied by 2. Our B is 5, so it's going to give us a horizontal, if B is greater than 1, it's a horizontal compression by 1 over B, so by 1/5. So this is the key part with the compressions and stretches for horizontal direction. It's 1 over the value. And C makes it move to the right by 1. Okay, and again, pause this when you need to so you can write it down and think about it, or plug in your calculator to see it if you want. These are a bit more difficult, I think, though, to see than quadratics. Okay, second one, we've got an A, a B, a C, and a D. So A is less than 1, so it's going to be a vertical compression by the value of A, which is 1/2. So we don't manipulate that at all. B, again, is greater than 1, so it's a horizontal compression by 1 over B, so 1 over 3. C is positive, so it's going to move right by 4. And D is positive, so it moves up by 5. Okay. Next one, we've got an A, we've got a B, a C, and a D. So, vertical stretch by 6, because again, A is bigger than 1. B is less than 1, so that's going to be a horizontal stretch by 1 over 1/2, which is equal to 2. Really all you're doing is taking this fraction and inverting it. So 1/2 inverted is 2, so it's a horizontal stretch by a factor of 2. That means each x value is multiplied by 2. C causes it to move right by 1, and D makes it move down by 3. Okay, we're almost there. Okay, on our next one, notice this one's a little different in that we have 2x. Remember, to do a translation, to evaluate our function, our equation had to be of this form. The b has to be separated from the x. So the x minus the c value is inside the parentheses. B is factored out because you have to have a single x to figure out your horizontal translation. So it means we have to do a little bit of work here. So whatever x is multiplied by, I need to factor out. So I leave my parentheses, the third power, and the plus 1. But I'm going to pull this 2 and then put a new parentheses in here. So if I take 2x and divide it by 2, I would have an x left, which is what I need. But I have to do the same thing to this term. So negative 4 divided by 2 gives me a negative 2. Now I can evaluate it. I have no a value outside the parentheses. B is 2, so that tells me it's a horizontal compression by 1 over b, so 1/2. C, I can now tell what it is because I have a single x in here. So I'm going to move to the right, let's just draw an arrow, to the right by 2, not 4, but 2. And I move up by 1. Okay, one more where we have to do a bit of work. This one again, we've got 3x instead of a single x, so I need to do some factoring, factor that 3 out. So we leave the 2 all the way on the outside, and we make our big parentheses and leave the 7 on the outside. So now inside this parentheses is where I'm working. I need to factor the 3 away from the x. So if I factor it away from the x, I have to factor it out of the negative 15. So negative 15 divided by 3 is negative 5. And now I can just say or describe the changes. 2 causes a vertical stretch by 2. The 3 causes a horizontal compression by 1 over 3. 5 makes it move right by 5. And D makes it move down 7. Okay. Again, take each number by itself as you're trying to describe it. Don't look at the whole equation and feel overwhelmed. So now we're going to write the equation. And anytime we write an equation, we have to start with y equals. So y equals, and it's a cubic function, of course. So we're going to do a vertical stretch of 4. So that's my letter A. Put that out in front. I'm going to move left 5 and down 8. So to move left, that's going to be the letter C. To move down, that's D. So notice I don't have any horizontal compression or stretch. So I just have X. If I'm moving left, it's minus a negative 5, so that becomes a positive 5 cubed minus 8. Okay, now we have a vertical compression by 1/4. We move right and we move up. So again, there's no B value for this one. So y equals, my vertical compression is 1/4. I move right, so it's going to be x minus 7 cubed. And I want to move up, so I add this value, 5. Okay, finally, we get a horizontal. We've got a horizontal stretch, but there's no A value here. So we just start with our parentheses right away. Stretch by 3. So to find the B value, it's 1 over that. So 1/3. I want to move right, so that's a negative. Make sure you have the 2 closed parentheses here to the 3rd power. And I need to move up 9, so plus 9. So again, no A value. I've got my B value, C, and D. Okay, last one here. Horizontal stretch, that's a B. Left is C, and down is D. So y equals, parentheses, a stretch by 2, so that's going to be 1 over 2 to find the B value. X, and I'm moving left, so that becomes a positive 1, close parentheses twice, cube it, and minus 14. So we have moved down. Okay, hopefully you've stuck with me. So let's do one more, and this one's just a little different. It's just expanding and stretching what you already know. Up here when we were moving them, and here, we were always moving compared to the parent function of f of x equals x to the 3rd power. What we're doing down here is, what if we have a function, it's a cube, x minus 2 plus 3. So this one has moved to the right 2 and up 3. Let's make that our starting point. How would we have to move from this function to get to this one? So this one is to the right 2 and up 3. But this one is, if it says plus 3, that means it's to the left 3. So if I'm already to the right 2, I need to go left 3. How far is it from positive 2 to a negative 3? So that's 5. And which direction? That means we have to move to the left by 5 to get these two. Now this one was at positive 3, and now I want to be at positive 1. So in the y direction, I need to move downwards by 2. So I'm simply taking the y value of my starting point minus the y value of the end location. Likewise with x. I took my starting c value, which was a positive 2, and I subtracted the ending c value, which was a negative 3. So 2 minus a negative 3 gives me the 5. Okay, well, let's take a look here. this one finishes at +5, -4. So if we were at +2 and we want to get to +5, we need to continue moving right by 3. Likewise, if I started at +3 and I want to finish at -4, I have to move down 3 and then move down 4 more. So that's going to make it move down by 7 total. Okay? Okay, guys, there is homework for you. You should be able to get through it in class, and go ahead and turn it into the sub or put it on the small table with the calculators in the basket. Okay? If you need to work on extra credit to boost your grade by 10 points, the sub can give it to you. You have to work individually to turn that in. Okay? We will have a review next class and then a test the following class. So you're in the home stretch.